lesson 3-4, work and energy, and of course power. All right, we've talked about work and energy in the previous lesson, work being FD, energy being either kinetic or some form of potential energy or even perhaps heat. And now we want to bring in power, which is a little bit different and sometimes confusing. All right, so many people do confuse work, energy, and power. As stated earlier, work involves a transfer of energy. Energy is the ability to do work. Both work and energy are measured in joules. Now, power is the rate at which work is done. So if you got paid $12 per hour, your rate of pay would be $12 for every hour. That's different than how much money do you have. If you've got $500, that's kind of like your work or energy, and it's measured in joules. Whereas power is how fast do you make money. Some people make $12 an hour, some people make $12,000 an hour. All right, so power is the rate at which work is done. It's measured in joules every second, or work divided by time, and of course the unit is called the watt. So power is equal to work over time, and of course the unit for work is delta E, or the change in energy. The unit for work is the joule, and of course time is measured in hours, seconds, minutes, days, years, but we usually use the standard unit for time, which is the second. So a joule per second is called a watt. And so you often see on a power bill so many kilowatts of power are being used. Or the old style light bulb might have been 60 watts. The new ones that are more energy efficient are something like 13 or 14 watts, because some of the energy that they use with the old standard light bulbs, they would get very hot. So a lot of that energy that they were using was turning into heat. The new style, fluorescent style bulbs give off lots more light and a lot less heat, and so you're getting what you're paying for, and you're not heating up your house. Now, here's an example of a couple of students doing some work. So what it says is two students, each with a mass of 70 kilograms, climbs a flight of stairs that is 4 meters high. Student A takes 20 seconds and student B takes 30 seconds. All right, so the first thing I would ask is a more rhetorical question. All right, more work? Did student A do more work, or did student B? And of course, who had more power? So I usually ask students to sort of, by a show of hands, express their sort of opinion without doing any mathematics. And then what we do is we look at the math. So think about this for a sec. Who had more power is the interesting one. So let's take a look at the solution to this. Here's the question, and here's the solution to A. How much work did student A do? Well, student A took 20 seconds, but how much work did he or she do? Well, the work done is, of course, the change in potential energy, because you're going up the stairs, and potential energy is mgh. So we take the mass of the student, 70 kilograms, times gravity, 9.81, and the height of the stairs is 4 meters. And we have 747 joules. And here's the units. The kilogram times the meters per second squared gives you a joule. All right, actually that should be a kilogram meter squared. All right, so there's a little bit of a problem with this unit. Yeah, because it should be a kilogram right here times a meter, that's a meter squared. So this should have a meter squared on it. All right, a little typo. In any case, because each student did the same or had the same mass and climbed to the same height, both students had a mass of 70. Both students climbed to a height of 4 meters, so both students did the same amount of work. And we would round that 2747 to 2.75 times 10 to the 3 joules, or 2.75 kilojoules. Now we have to do the next calculation separately. So for student A, we take to find the power, we take the amount of work the student A did, divide it by the time. She did 2747 joules. It took her 20 seconds. 2747 divided by 20 gives you 137 joules per second, or 137 watts. So student A had a power of 137 watts. Now if we look at student B did the same amount of work, 2747 joules, but it took her 30 seconds to climb those stairs. Therefore, dividing the same amount by a greater time gives you a smaller number, only 91.6 watts. All right, and compare that to some light bulbs that you have. A 100-watt light bulb is fairly common. So these students are giving off energy as something close to a 100-watt bulb. All right, so because student A did the work more quickly, he or she had more power. Student B had less power because it took longer to do the same amount of work. So work is measured in joules, power is measured in joules per seconds, or watts, and it's the rate at which work is done.